Hello everyone, and welcome back to class. Welcome to the Earth Science unit in the course. This part of the course, we are going to be talking about the dynamic nature of our planet and how do we communicate to our learners about the different types of minerals, rocks, deep time and plate tectonics, and a variety of other subjects dealing with Earth science. Now, when we start talking about Earth science, we need to start at the fundamentals because that is how we communicate the larger, broader topics later in the course. I'm actually now broadcasting along Corridor H. As you can probably hear the cars that are driving by rather quickly, but our area, Appalachia, is well known for a lot of mountain building processes that allow for us to better understand the dynamic and changing nature of our planet. Sitting smack dab in what they call the Tolaway group. It's a Paleozoic, so it's before the time of the dinosaurs, units of rock. It's actually part of the Appalachian system. But I want to show you something. In class, we're going to be talking about minerals this week. And take a look at that. This right here is a deposit of a mineral. Now, we have to ask ourselves, our students, our learners will wonder. They'll be like, teacher, I wonder what kind of mineral this is. And in this week's unit, we are going to investigate that. We are going to look at the physical properties different minerals have and use those as a conceptual framework to communicate Earth science. So what we can do is we can take a piece of this mineral. I've actually already identified it. It's gypsum, and use basic property tests, such as being able to just lightly scratch it. The hardness of a mineral, along with its crystalline habit or how it grows, are good characteristics for us to be able to identify different types of minerals out in the field. There are also other characteristics such as color, reaction to acid, even the weight of the mineral itself. And we use these as a way to put the natural world into organized boxes so that way we can take that box and open it up for our learners to explore and investigate the model. Okay, we are back from being out in the field. It was a glorious day out there, and we got to see some really cool local geology. But our goal in this unit, in the minerals unit, is to be able to talk about the physical characteristics of the minerals we work on in class. And our goal as educators is to allow for our learners to interact with these at their own pace using their sense-making skills. And you're there to collaboratively guide them through better understanding the world around them. You do not need to be a complete expert on the classification of rocks and minerals for this course. I just want you to conceptually understand that earth scientists have a way to identify not just the features and physical properties of these different minerals, but it helps us better understand the distribution of these resources. So right here, I have a little, it's the Colorful Mineral Collection. You can buy these at any science supply store. This one came from Ward Science. Ward Science, if you're watching this, please sponsor my channel. But they're wonderful kits. And you can actually build your own kit. You don't have to go out and purchase your own. That one was about $35. But if you go out and you use these physical properties tests that I talk about in the field recording, you can go out and effectively build your own using an online database. Now let's talk about some of those physical properties real quick. So physical properties Earth scientists have used them so that way we can properly assess how we look at minerals. Because there's quite a few different minerals in our planet. I think the most recent count is over 4,000 naturally occurring minerals. And each mineral has their own unique set of properties that keeps them separate and easy to name. And we have to communicate that to our learners of these are the properties of what makes this mineral what it is, because it helps answer their wonders. Why, or a student may wonder why two minerals such as these are virtually the same on their hardness. If they take a glass plate and use the hardness test and scratch it, they will wonder why they have that same property. And that's when you can go in and talk to them about other properties and guide them to the explanation that both of these are variations of the same mineral called quartz. The only difference in their physical property would be this one having different chemical composition than this one as it formed. Another student may wonder why or what characteristic may allow us to identify this mineral as sulfur. And that's when you can appeal to their sense making, literally by just scratching it and smelling it, and it will smell like rotten eggs to them. And so these are activities you can do with your learners. Other physical properties that minerals may have would be special properties. And we can use these to effectively diagnose, much like how a biologist classifies an animal, the uniqueness. For an example, when we take a look at this mineral right here, it's called magnetite. And magnetite will actually stick to a variety of metallic surfaces. Piece of magnetite, I've actually got a small little magnetic stir rod, and its special property is magnetism. So I can put the stir rod into it. There's actually a little magnet that runs through it, but it's attracting to the piece of magnetite. So the takeaway is that a learner can use maybe at most 3 characteristics in their identification of a mineral with your help. We can even take, excuse me while I take a quick shot of my coffee. We can even take acid. This is actually a bottle of hydrochloric acid. It's the same strength as table vinegar, so it's actually not that dangerous. And we can take a little bit of acid and drop it on this piece of calcite and watch the calcite effervesce or fizz as a reaction to it. And the rate of that reaction will tell us that piece of calcite is part of the biochemical or the chemical group of minerals, unlike, let's say, those quartz. If we look at the chemical composition of quartz, it's going to be mostly silica. So that actually separates and puts the calcite over here, and the quartz is over here. It's all about organization this week. How do we organize minerals into very small boxes, then allow our learner to open up those boxes and investigate? All right, if you have any questions, feel free to reach out. You can get a hold of me on Zoom, email, or just swing by my office. Thank you. Have an excellent day and keep learning in GSC 101.